How's it going, guys? It's Chris. I'm going to be presenting more on the mechanics of corner running, this time focusing in a little bit more on research strategy and what I'm planning on doing with my thesis. We'll quick review the motivation for this study and why we're even interested in corner running. They've found that there's a much higher rate of injury during indoor track, about 2.3 injuries per 1,000 athletic hours of training. Primarily in middle and long distance runners. And to picture this, you can think of a team of 20 training for 2 hours a day, 5 days a week. In the span of about a month, between 2 and 3 of those athletes will experience one injury. These injuries, on average, take people out of competition and practice for 8.1 days. And once you factor in actual medical costs, decrease of future earnings, and also assign a monetary value to a decline in quality of life, these injuries can end up costing upwards of $10,000. And all of this happens because of the gait changes and asymmetries that are introduced when an athlete is running around a curved path. So hopefully everybody remembers my activity from last time. There is a lot that is different between running straight and running around a turn. Most of this stems from the fact that an athlete has to counteract those centripetal forces that come with running around a corner and position their body in a way that allows them to produce force that will counteract that centripetal force. We narrowed in on 6 specific metrics that may be higher injury predictors or just bigger indicators of something that's actually changing when running around a corner. We talked about a couple of the popular interventions for these changes, the primary one being running on a banked track, where if you can orient the surface on which an athlete is running perpendicular to the force vector that the athlete is producing, a lot of these issues will naturally resolve themselves. One study took this and applied it to a shoe-based intervention where when they banked the shoes, they were actually able to observe statistically significant increases in ankle plantar flexion moment, centripetal ground reaction force, and maximum curve sprinting speed. So essentially what that means is when they banked the shoes, they were able to see some similar qualities as an athlete would experience when running on a banked track. So basically the idea is that by implementing an angled carbon fiber plate into competition shoes, we will be able to achieve a similar result to that of running on a banked track, where the response from the carbon fiber plate would be oriented parallel to the force that's imparted by the athlete. I think my design idea was a little bit unclear the last time I presented, so I tried to make it a little bit clearer on this slide and the next one. Where basically the idea is to make the cross sections of this layer and this layer triangular, so then the carbon fiber plate is oriented at an angle with respect to the ground. So this is a back view of the insert where you can see this first layer is at an angle, so then when the carbon fiber plate is secured to it, it will be oriented at an angle as well. To manufacture this, I'm planning on starting with 1/8 inch layers of EVA and gluing those together and then machining out the contours like you see over here. So we'll have the layers stacked up and then we'll machine out the proper shape for both sides. And then we'll have a mold for the carbon fiber plate where we'll do hand layup of carbon fiber and cure it to get a nice contour shape there as well. And then after that, it's just a matter of gluing all these layers together, and we've got our prototype. To collect the data, the sample that we'll be taking data from will be 15 male and 15 female, primarily 400 to 10,000 meter athletes. They will be required to have no injury in the last 12 months, where injury is defined as anything that requires taking time away from the sport. 30 people as a sample size is relatively low to be able to draw any sort of correlational relationship from, but for a pilot study, it'll give us a pretty good idea of whether or not this idea is working, and then we can move forward with more in-depth studies. To collect the data, we'll be using a wearable IMU suit, which will give us motion data about each limb of the person that's running. And we'll use that in conjunction with an EMG on the inside calf to get feedback about that gastroc medialis. So those two things in combination will give us the ability to track those 6 metrics I was talking about earlier. This study was originally designed to use force plates and motion capture along with that EMG to get the data. So if we're not sure of the capabilities of the IMU suit yet, but if that ends up not working, we'll have this original design to fall back on. For the actual data collection itself, we'll start with a 10 to 15 minute warm-up protocol, and then athletes will complete 12 60-meter strides, 3 for each of the possible combinations, with and without the plate for straight and corner running. There will be 2 minutes of rest between the reps, and then we'll end with 10 to 15 minutes of cool-down protocol. So the whole thing is designed to take a little bit over an hour. For data analysis, the tricky part here is that we don't want to just compare each running scenario to each other running scenario. We want to compare how similar it is to that baseline trial of straight, unplated running. So the idea is that we can calculate a similarity index. For example, over here, if the ground contact time for a corner running plated scenario was 0.24 seconds, and then for the straight unplated scenario it was 0.2 seconds, that would give us a similarity index of 1.2. And then once we have these values, we can do 2 paired t-tests to compare corner plated running versus corner and unplated running, as well as corner plated running versus straight plated running, to really get a good idea of how those angled carbon fiber plates will impact every form of running with them. Thanks for listening. If you have any questions, feel free to email me, and I'm sorry that I could not be there in person.